Good afternoon. My name is Javier Rodriguez, and today we'll be doing a practice problem from Math 1000, which is basically Calc 1. Okay, so today's problem involves related rates. Related rates involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rate of changes are known. Our problem brings a rectangle who is inscribed in a circle of radius r units. So here's our circle, and there's a rectangle inscribed inside. Since it's inscribed, we can relate the radius of the circle to the rectangle. See, the circle has a radius of r, which traces back to this middle right here, which we can call r. Now for this circle, if the length of the rectangle is decreasing at the rate of p units per second, how fast is the area changing when the length is L units? Alright, so from this first statement, we get to understand that the length of the rectangle equals L. Alright. You want to try to write down every single fact that the question gives you so that you have a better understanding of what exactly is you have to do or find. Equals L. So we can just write that down here. That's an L. Right, now it says that we should also note that the volumes R, P, and L are of real numbers. Which means the derivative is not going to be just 1 because they're not a variable. Also, we have to note that the radius is constant. Since the radius is constant, dr over dt, which is the derivative of dr of the radius, or the rate of change of the radius, will equal 0. Alright, so we have those two facts, and we know since we want to find the rate of change of the area, we do dA over dt, where dA equals the area, so there we get the rate of change of the area. That's what we want to try and find out. And now keep in mind that the area of a rectangle equals length times width. So we have to find the derivative of this. Okay, so let's start here on a new page. Now, since we know that there's a rectangle inscribed right here, and here we have these two lines, we get to understand that this over here, that this is a special triangle. Since there is a 90-degree angle in each corner of the rectangle, over here we'll have 45 degrees and 45 degrees. Now if we trace our triangle outside, you can find out it's a special triangle that has 45 degrees here, 45 degrees here, and a 90-degree angle here. Since the area of the triangle is supposed to equal 180 in total. So 145, and then over here we have 90. Now, since we just found out about those angle values, we can determine this is a special triangle, and then go and say x equals x here, and this equals x times the square root of 2, because that is a defined theorem. Now, over here, since we already have r and r, we get to know that this part right here equals r to the square root of 2. Now that we have that value, we can find the derivative of the area of the rectangle, or dA dt. So dA dt, so now the area changes to L, which is the length, times R times 2, which is the width of the rectangle. Now we have we can derive and find dA dt. So for this, we utilize the product rule, which is the derivative of the first number times the second number plus the derivative of the second number times the first number. So we have L times the square root of 2 times dr dt, dr over dt all that summed to dl dt times r times the square root of 2. Right, so we have that. Now, once we have that, we can remember that dr dt equals 0. So since we know that, well, because it's to know that the derivative, so we can start substituting values inside of derivative. So then, since the first value was L times the square root of 2 times dr dt, that value will now be 0. Now we have to sum that plus dl over dt times the square dl over dt times the square root of 2 times r. So by that, since we know what dl dt is, which is negative p, because the rate of the rectangle is decreasing at p rates, and since it's decreasing, that's why it will be negative. This will equal negative p. Oh, sorry about this x right here. Don't get confused. So now negative p times square root of 2 times r, and that will equal area of the rectangle, the rate of change in the area of the rectangle, because we have no known values. All we have are variables or letters, which, although they represent normal real numbers, we don't have an exact value for them, so we can't do anything else. And this will be our final result. There you go. Smile if you understand it. There you go. I hope you enjoyed the exercise. I didn't understand the exercise, and if you have any further questions, please feel free to email me or contact me via office hours. I hope you got a good afternoon, and this has been Professor Javier Rodriguez.